Good morning, students. Today, the topic that we are starting is a part of Unit 2 Algebra and Graph of O levels and IGCSE. And the topic that we are discussing today is graphs in practical situations, right? Means where you apply it in your daily life. Now, so the type of graph that we are discussing today is distance time graph and velocity time graph, right? So we will see how distance time graph look like and how velocity time graph look like in practical situation. Okay, so let's start the video. Okay, so before starting with the worksheet, you need to understand some basics of this. Okay, because this is very important, right? So first we discuss about the types of graph. So first we have a distance time graph. Distance time graph. Okay. So suppose in distance time graph, y-axis we take distance, y-axis we take distance, and on x-axis we take time. Yeah, this is distance and this is time. Okay. So if your graph is like this, what does it means? It means that the time is passing, but the distance remain constant. So when time is passing or distance remain constant means body is at body is at rest position. Body is at rest position because the time is passing, but the distance is same. So body is at rest position. Okay. Another another graph could be like this. Again, y-axis and x-axis we will draw. Here we will have distance. Here we will have time. Okay. Now, if your graph is going like this, it means uniform speed. What? Uniform speed. Because you see, at equal time interval, distance is increasing equally. So except for example, if it is 1 second, so distance covered is 50 meter. Then 2 second, distance covered is 100 meter. Then in 3 seconds, distance covered is 150 meter. So we can predict at 4 seconds how much distance has been covered. So whenever we have this type in which we can identify the distance covered in next second, that is called uniform speed. But generally we don't see this type of uniform speed in our daily life. Is it possible to go with the same speed in a real life? No, it is not possible. Yeah, and also we need to understand that if we have to find the slope of slope of distance time graph, so if you find slope of distance time graph, it will gives us acceleration. Slope of distance time graph gives us acceleration. So it means change in value in y divided by change in x. So we call it delta y upon delta x. Delta means how much is the change in the value in y-axis and how much is the change in value in x-axis. That will gives us acceleration. Okay, delta y upon delta x. In place of x, we have time here. So in x-axis, time is there. So basically this, right? So slope of distance time graph, instead of x, we can write t so that you will not get confused. Change in distance divided by change in time gives us acceleration. And in physics, you have studied the formula v minus u upon t. V means final velocity, u means initial velocity. So change in velocity, v minus u upon t. Okay, so this is uniform speed graph. Now, if we talk about non-uniform speed graph, so this is your y-axis and this is your x-axis. Again, same thing, y-axis and x-axis. This is again distance or displacement and this is time. If the graph is going like this, it's increase suddenly, there is a rise, suddenly there is a drop. So when this type of condition is there, we called it non-uniform speed. So here we have a non-uniform speed. Okay. This is distance time graph. Now, most importantly, the questions that you will get in exam in O levels and IGCSE is from another type of graph which is called velocity time graph. Okay, velocity time graph, right? So what we do in velocity time graph, same graphs are there but in y-axis we have velocity right now. So velocity on y-axis and time in x-axis. Okay, so velocity time graph. Okay, so if line is parallel to x-axis, it means uniform velocity. Body is moving with a uniform velocity. Time is passing, but velocity remains same. So that is called uniform velocity or constant velocity also you can say, right? If graph is going like this, suppose this is y-axis and then this is x-axis, okay? And again this is velocity and this is time, okay? And your graph is like this. So this is called uniform acceleration, right? Uniform acceleration is happening here. And also slope of velocity time graph, slope of velocity time graph gives acceleration. Slope of velocity time graph gives acceleration. Okay. Oh, I'm sorry, I made a mistake here. I told you slope of distance time graph give acceleration, which is wrong. I'm sorry. Slope of velocity, slope of distance time graph, slope of distance time graph gives velocity. Slope of distance time graph give velocity. I was thinking velocity and saying acceleration, right? So my mistake, apologies. Slope of distance time graph gives velocity. So change in distance over time, delta y upon delta t. You know the distance upon time is speed. So slope of distance time graph gives velocity, whereas slope of velocity time graph gives acceleration. Okay, right. Next, uh, same conditions are there if we have a y-axis and x-axis. This is y-axis and this is x-axis. Just a second. Yeah, so this is velocity time graph, this is velocity, again y-axis, and this is time. And if the graph is going like this, you understand that this is non-uniform acceleration. Here we are talking about that formula, v minus u upon t gives acceleration. Yeah, so slope of velocity time graph give acceleration. And also one more thing, if please make a note, this is very important point. If in velocity time graph, if in velocity time graph they ask to find this, they ask to find distance. I'm talking about velocity time graph. Yeah, if they ask to find distance, then we need to calculate area under the curve. Then we need to calculate area under the curve. This is very important, very important. Uh, because in almost every question you will see that they are asking you to find the distance covered in a graph in a particular time. Then you have to find the area under the curve. Okay, so these are the basics of this topic. Now let's start with the question. Question number first. An animal starts from rest and accelerates to its top speed. An animal start from rest means it is starting from zero and accelerates its top speed. What is the top speed of the animal? 14 meter per second in 7 seconds. It continue at this speed for 9 seconds. For the next 9 seconds, it is going with the same speed and then slows to a further stop, and then finally it stops in next 4 seconds. Okay, you have to find the acceleration for the first 7 seconds. So acceleration formula, as I told you, is change in velocity over time. if you are physics student, you must have studied in physics that acceleration is v minus u upon t, where v is called final velocity and u is called initial velocity, right? Final velocity and initial velocity. So final minus initial means change in velocity, right? So final is 14, initial is 0, and how much is the change in time from 7 minus 0? 7. Okay, so 14 upon 7, how much we are getting? 2 meter per second square. That is acceleration. That is acceleration, right? Now write down its speeds 18 second after the start. 18 second after the start. So 0, 2, 4, 6, 8. This is my 18 second. So after 18 second, what is the speed at that time? See, you can see from the graph. If we go up, from here, from 18, if we go up, it strikes here, and exactly if we check here, so it is coming exactly between 6 and 8. So speed 18 second after the start is 7 meter per second. You can see at 18 we go up, and then we draw a line parallel to x-axis where it is hitting exactly between 6 and 8. So speed 18 second after the start is 7 meter per second, right? Now, I told you na, in every question they ask you to find the total distance traveled. Here it is. You see, find the total distance that the animal traveled. Now this is a speed time graph. To find the distance traveled, I need to find the area under this curve. Now, if you see this figure, it is looking like a trapezium. Yeah. So we have to find the area of the field. So total distance traveled is equals to area under the curve. Total distance is equals to area of figure, trapezium. Yeah, and we all know the formula of trapezium is half a plus b times height, where a and b are the parallel sides. So these are my parallel sides, this and this are parallel side, and this is the perpendicular height between them. Okay, so a and b are the parallel sides. Now put the value of half a. A means the parallel sides distance from here until here. So 16 minus 7, how much? 9. So A is 9. 16 minus 7, A is 9. B is 20. B is 20, you see, from here until here, it's 20. And what is height? 14. From here, 0 until 14, this is height. So B is 20 and height is 14. Put the value. B is 20 and height is 14. Cancel it with 2. 2 times 7. So 29 times 7. That will be my total distance traveled. Multiply 9 times 7, 63. 7 times 203 meter. That will be the answer. Clear? Easy, right? Next question. This is again another distance type graph is given for 120 seconds of a car journey. Right. Calculate the deceleration of the car during first 20 seconds. Now, what is deceleration? Deceleration is basically negative acceleration. What is deceleration? Deceleration is a negative acceleration. When the speed is decreasing with time, we called it negative acceleration. So, as you can see here, the final velocity is this 10 and initial velocity is 18. And how much is the time? 20. So, acceleration is v minus q upon t. Acceleration is v minus u upon t, where v is the final velocity. So, final velocity is 10 minus what is initial velocity? Initial velocity is 18. Right, so 10 minus 18 upon how much is the time? 20. So negative 8 over 20. 4 times 2, 4 times 5. Yeah, so minus 2 over 5, it is coming. Minus 2 over 5 meter per second square. If you want to write it in decimal, you can write as negative 0.4 meter per second square. That is your negative acceleration, or you can say retardation. Negative acceleration or retardation. I hope it is clear. Deceleration. Next part. Calculate the total distance traveled by the car for the 120 seconds. Now same. 120 seconds from 0 until here. So you have to find the total distance traveled. So you have to find the area under this curve. Now if you see, if I break this figure has been divided into three figures. If I join from here until here, so one trapezium, then one rectangle, this is a rectangle, and this is another trapezium. Two trapezium and one rectangle, right? So this is figure first, this is figure second, and this is figure third. You add the area of all these figures, then you get the total distance traveled. Okay, total distance traveled. Okay, so there is less space, so I am solving it here. Total distance traveled is total distance is equals to area of figure 1 plus area of figure 2 plus area of figure 3. Figure 3, right? So figure 1 is a trapezium, same formula, half a plus b times height. Now here these two are parallel sides, 18 and 10. Formula is half a plus b times h plus length times breadth plus same a plus b times h, same two trapezium and one rectangle. Values will be different. Half a plus b times h. So a is 18, b is 10, and height is 20. 18 plus 10 times 20. 18 plus 10 times 20. So 2 times 10 plus length times breadth. Length is from 90 to 20 to 90 is 70, and width is 10. 70 times 10 plus half a plus b. This is 10 and this is 20. So half 10 plus 20 times height. This from 90 to 120, it's 30. Okay, so 18 plus 10, 28. 28 times 10, 280 plus 700, half times 15, and plus 30 times 15, 280 plus 700 plus 450. Add it, 1430 meter. That is the total distance traveled, right? Now average speed. Average speed is total distance upon total time. Average speed is total distance upon total time. So average speed, C part, total distance divided by total time. Total distance, so we just calculated, right? 1430 meter divided by 120 seconds, right? So this will be 11.9 approximately meter per second, right? Okay, so third question is also similar to like this question. You have to find the distance in kilometer between the two stations. The time is in minute, so you have to convert it into kilometer first, right? Rest all procedure is same. After finding the distance, you can find average speed by total distance upon total time. Now you see here the speed is in kilometer per hour and time is in minutes. So you have to convert it into hours. How? Divided by 60. Yeah, only that you have to keep in mind. Rest all everything is same. Apply area of trapezium formula, half a plus b times h. A and b are 26 and 19, but it is in minute, so divided by 60, and then height is 40. Okay, so I am leaving this question for you to try this. If you are not able to do it, then you comment, I will solve it for you. Okay, next question number 4th. Yeah, this is a graph given. Question number 4. What it is say, the diagram shows the speed time graph for 70 seconds of a car journey. After 20 seconds, the car reaches a speed of v. During 70 seconds, the car travel 1375 meter. Calculate v. Okay. Now, as you can see that we have to find the value of v, right? And the distance time graph is given for 70 seconds of a car journey. This is the 70 second of the car journey. And after 20 seconds, they say after 20 seconds, the car reaches to a speed of v. Okay, so during 70-second car travel and total 1375 meter is given. So generally in all the questions we are calculating the distance, but here in this question we have been given distance and you have to find the unknown v. So you know the procedure is same. Yeah, calculate the area of this graph. uh, you know that total distance is equals to a part of question 4. Total distance is equals to area of graph, area under the graph. So base is half a plus b times h, half a plus b times h. Total distance is 1375 meter. Half a base, base is 70, 70 plus a b is 20 to 60, which is 40, and height is v. So half 70 plus 40, 110 times v is equals to 1375. So v will be 1375 divided by 55. Cancel it with 5. 5 times 11, 5 times 2, 10, 5 times 7, 35, and then v 25. So v is coming 25 meter per second, right? Now they say calculate the acceleration for the first 20 seconds. After you get v, you find acceleration. So acceleration formula is v minus u upon t. Final velocity so we already calculated, right? 25. So 25 minus 0 upon 20. So 25 upon 20, 5 times 5, 5.4, 1.25 meter per second square. This is your answer, right? Okay. Now again this same question is there, right? In this question, the diagram shows the speed time graph for 100 seconds of a car journey. The car accelerates uniformly from a speed of v to 3v in 50 seconds. Then continue at a constant speed. So say find the acceleration in terms of v. So acceleration, you know that change in velocity over time. Yeah, change in velocity over time. So what is the change in velocity from v? The velocity changes to 3v. So change in velocity 3v minus v upon 50. 2v upon 50. So v is v over 25 meter per second square, right? Now they say car traveled 2500 meter during the 100 second. So you see there is two, there will be two figure here, figure 1, figure 2. Figure 1 is trapezium and figure 2 is rectangle, and total distance is given. You have to find the v. Okay, so to do the v part, I'm doing it here. Total distance is equals to area of figure 1 plus area of figure 2. Okay, so figure 1, half a plus b times h plus length times width, right? So you see what is a and b here. A is this parallel sides, so this is v and this is 3v and height is 50. Okay, so half a plus b, half v plus 3v times height is 50 plus length times breadth. So length is 100 to 50, it's 50, and width is 3v. Okay, and the total distance is given 2500 meter, right? How much? 2500 meter. So this is given 2500 meter. Okay, so half times 25. So v plus 3v is 4v. 4v times 25 plus 50 times 3v is 150v, and this is 100v. 150v plus 100v is 250v. 250v equals to 2500. So v will be 10 meter per second. I got the value of 10. Now the speed, you have to find the speed of car in kilometer per hour when time is 75 seconds. Now 75 seconds will be somewhere here in between. At that time, what is the speed? 3v. 3v means 3 times 3v means 3 times 10, 30 meter per second, right? So to convert meter per second into kilometer per hour, there is a shortcut. Multiply it by 18 upon 5. 5 times 6, so 108 kilometer per hour. So there is a shortcut here in physics. This will be very helpful for you if you have to convert anything from kilometer per hour into meter per second. Yeah, if you have to convert anything from kilometer per hour into meter per second, multiply by 5 upon 18. And if you have to do the reverse, okay, from meter per second into kilometer per hour, so you have to do reverse, multiply by 18 over 5. So this is a shortcut. You can quickly use it to change from meter per second into kilometer per hour, right? Now question 6 is also similar to question 6 is also similar to all question 5, question 4. So you try this question, okay? I know the diagram might be looking complicated for you, so that is a challenge for you guys. I know you all can do this question, right? If you cannot do it, you know what you have to do. You just have to put in a message in comment section. I will solve it for you. But I know you can do it. Only the diagram is looking complicated, but it's very easy. Yeah. Okay. So try this question. Okay. Next question number 7. The diagram shows the speed time graph of a train which slowed down from 20 seconds to a stop in t seconds. Okay, so diagram shows the speed time graph which slow down. Means whenever a body slowed down, that is called retardation or negative acceleration. So formula of acceleration is change in velocity over time. Initially velocity is 20, now it becomes 0. So 0 minus 20 over t. So negative 20 over t is the answer in terms of t. Okay. Now they say find the speed of the train when t is 3 over 4 of t. Okay. When t is somewhere here, 3 over 4 of t, they are asking speed. Now you know that formula of acceleration is v minus u over t. Okay. So acceleration, we already got negative 2 over t, and they say when time is v, we have to find initial velocity is 20 and time is 3 over 4 of t. Okay, 3 over 4 of t. Now this 4 go up, so negative 20 over t is equals to 4 times v minus 20 upon 3t. T cancel, cross multiply, minus 20 times 3 multiply 4v minus 80. Minus 80 go that side, becomes plus 80. So 80 minus 60, 4v equals to 20. So v is coming 5. So 5 meter per second. Distance traveled by the train from t0 to t is 150. Find t. Okay. Now you see this is a triangle forming. So to find the value of t, we find the area of the figure. To find distance traveled is equals to area of the figure, which is half base times height. Distance traveled is already given 150. Half, what is base given in this question? Base is t and height is 20. Okay, 2 times 10. So the t 150 divided by 10, that is 15. Okay, so what is the t? Time is 15 seconds. Okay, on the diagram, sketch the distance time graph for the train. Okay, now as you can see, the speed is decreasing with time. Okay, so you have to show the distance time graph of the train. Okay, so what is this? Initially speed is 0. Initially the speed is 0. Yeah, so you see, if I have to find the distance covered here, so distance is saying 150 meter has been covered, right? So t0 to is 150. Basically the distance is decreasing with time. Yeah, so uh, uh, sorry, the speed is decreasing with time but the distance is increasing, right? So this is distance traveled. So how much distance has been covered by the train in 15 seconds? 150 meter. So this is how your graph will be in 15 seconds. How much distance has been covered by the train? 150 meters, right? 15 150 meter has been covered. Okay, next. Oh yeah, it's already there. I just have to, they have already given it. I haven't seen it back. Yeah, so they already given it. You just have to draw it like this. Okay. Okay, now next question. Again, same thing is there. You have the retardation between time t equals to 8 and 12 is given -4. Retardation is written 4, but when you apply it in the question, you write -4. So A is V minus U upon T, where A is -4. If you don't take -4, your answer may come wrong, right? So final velocity is 0, initial velocity is V, and time is 8 to 12, 4. Cross multiply. -4 times 4 is equals to -V. Negative negative cancel. V is coming 16 meter per second. So always remember, whenever a retardation is there, they will not give minus in the question. You have to put on your own. Okay. And now find total distance traveled. To find total distance traveled, you know what you have to do. There are trapezium. So half A plus B times H. Half A and B are the parallel sides. So from here until here, it's 8 plus 12 times height is 16. Cancel 2 times 8, 20 times 8, that is 160 meter, right? Okay. So this is it in this worksheet. I hope distance time graph is clear to you. Velocity time graph is clear to you. This is our chapter, graphs in practical situation, and you will see this type of question in physics as well. So it is common in physics and maths both. Okay, so stay tuned for the more videos. I hope you like this video. If you like it, please like, share and subscribe my channel. Thank you so much. Bye bye. See you in the next video.